Hi, my name is Lei Hua. I'm the apps guy taking care of the system level protection devices in Semtech. Here in this demo, we're going to present you the SurgeSwitch and the HotSwitch. First, as you can see here, this is a SurgeSwitch we developed. A SurgeSwitch is a voltage clamping device. So imagine you have a VBUS line and you have a high voltage go through the VBUS line, create some voltage stress. You place this SurgeSwitch from the bus line to ground and then to clamp the bus voltage to a certain level to protect the downstream IC. Our SurgeSwitch is not only a voltage clamping device, it has more than voltage clamping. It has also current sharing capability. You can put them in parallel to increase the peak surge current capability, and also you can put them in series to increase the voltage level. Before the SurgeSwitch, people use a traditional Zener type device to clamp the bus voltage. So for traditional Zener type device, it's just a pin junction. So for example, simple illustration, you have a P-type device, again it's the N-type device, you create a pin junction. And if you have enough reverse voltage across the pin junction, you'll create a Zener breakdown. The voltage across the pin junction will pretty much stay the same, even you have different current flowing through the pin junction. Like what we're showing here, we have a light blue, this is the surge current flowing through this Zener type device. And this purple one is the clamping voltage across this Zener type device. As you can see, the clamping voltage of the Zener type device keep going up and higher once the surge current goes higher and higher. So that's the typical problem of the Zener type device. The pin junction has no control over the current. It just keep going up. And another disadvantage of these pin junction devices, it has positive temperature coefficient, which means that the clamping voltage go even higher if you have a higher ambient temperature. For example, from 38 to 42, if you go up to 125 degrees C. But our SurgeSwitch has internal well-compensated reference voltage, and it has very strong feedback loop. So these two control components drive the FET to turn on the FET and clamp the voltage to a certain level, which is stable over the whole range of the surge current, and it's always stable over from -40 to 125 degrees C. That's the beauty of our SurgeSwitch device. The HotSwitch is basically series protection. It's like a relay. You have a voltage source. You have a relay here, which is the HotSwitch. It turns on and off. So once it turns on, the power goes through. Once it turns off, the power stops here. This part we're trying to promote is HotSwitch HS2240. This part featured integrated TDS2211P. That makes the HotSwitch extremely strong to handle the high voltage surge. So to demo that, we create this VBUS machine. Oh yeah, before I do the VBUS machine test, we can show that this is the backlight. We have a power, goes through the cable, goes through the HotSwitch, to power the backlight. And then I rotate the wheel. Yeah, actually you can hear the spark. And you can also see the monitor turns off because the high voltage spike generated. The EMI turns off, or somehow you can black out the monitor. And you can also see our backlight turns off because the OVP event, but it's recovered right away. That means our HotSwitch is still okay. Even you have thousands of volts generated here, but our HotSwitch still survives.